Hello, today's segment is algebra. What is algebra? Algebra is the use of an equation to solve for the unknown. The use of an equation to solve for the unknown. And what is an equation? An equation is the statement of two mathematical values that are equal or proportional to each other. So you use an equal sign to figure out if the two values are equal and or proportional. It does not have to just be algebra. It can also be percentages, because when you do percentage, you use an equal sign with the rule. Remember, we went over that to where you have in a percentage, part over the whole is equal to percent over 100. That is the formula. And actually, it is an equation because you're using two values or trying to figure out two values with the use of an equal sign. That's what an equation actually is. So in algebra, we may have A equals 10. For example, A equals 10. This is actually an answer for an equation because we have two values and we have the equal sign showing that A is equal or proportional to 10. What we must always remember is when we are trying to solve an equation for a value, a letter or a variable, that's the unknown, we don't know what it is, so we call it a variable or a letter, we always want it to be positive. The answer can never be negative x or negative y or negative a equals 20 equals 30, negative m equals 4. That can never be the answer. It's incomplete. You have another step to go. So your answer will always be positive. The variable, not the number. The answer of the variable, when you're trying to find the unknown is the variable. And it always must end up positive. So it's positive A equals 10. Why do I call this a positive A? Any variable or any numbers that has no negative sign in front of it is understood to be positive. For example, this is a positive A, this is a positive 10. Remember, in previous segments, I had explained to you that each number is understood. For example, this number is understood, an whole number, understood to be over 1 at all times. And it's also understood that it has a decimal point behind it. That's understood. Every number that you see that's written, for example, if I was to have 25 or 6 or 2 or 100, each one of them, this 100 is understood to be 100 over 1. That's understood. And it's understood to have a decimal behind it. This 2 is understood to be over 1 and a decimal behind it. This 6 is understood to be over 1 and a decimal behind it. This 25 is understood to be over 1 and a decimal is behind it. Every number is understood to be over 1. And it's also understood that there's a decimal point behind each number. That's understood. We must have that in our head as we go forward. So also with every number, it's understood that it's positive. Every number is understood to be positive. If it's understood, it's not written. That's what I mean by it's understood. Because if I was to write 15 or 20 or 6, they're all understood to be positive. And variables too. Variables are letters, like A, B, C. They're variables, letters, same thing. They're understood to be positive too. So if I have A, C, Y, or X, they're all understood to be positive. You do not see the positive sign in front of it. Sometimes it's written. Sometimes they'll give you positive 15 or positive C or something like that. But they don't usually write that. They just give you A, X, Y, and it's understood to be positive. The only time that they are negative, let me say this again, the only time that they are negative is when they have a negative sign in front of them. For example, negative 20, negative X, negative A, negative 6. That sign, that negative sign, must be in front of a number or a letter for them to be negative. If the sign is not there, if that negative sign is not there, then it is always positive. Please remember that. So here we have positive A. We don't usually say positive A, but if I say it, I would still be correct. Most of the time, we just say A. So A is equal to 10, which actually is the same as positive A is equal to positive 10, because they are positive. But it's understood. I don't have to say positive. It's understood that it's positive. If I had negative A is equal to 10, then the A would have to have that negative sign in front of it. Must have it for it to be negative. And there are times that you are going to be doing algebraic equations and you end up with an answer like this. Negative A equals 10. But we must understand that you will never have an answer where the variable is negative. You may have an answer where the number is negative, but never the variable, because you are always trying to solve for that variable, and the variable must always be positive when you solve the problem. Must always end up positive. Remember, your answer will always be, the variable will always be positive in your answer. The variable will always be positive in your answer. So here we have negative A equals 10. So that could not be the answer. You have to get rid of that negative sign in front of the variable. So what we do is, to get rid of a variable or a negative sign, we must remember that the variable, if it's just by itself, A, that's understood to be 1A. So this is actually negative 1A. The same thing as negative A. Negative A, negative B, negative X, negative Y, they're understood to be negative 1A, negative 1B, negative 1X, negative 1Y. Sometimes, or most of the times, they do not write the 1. They just say negative A, but it's understood to be negative 1A. And to get rid of the number in front of the variable, or to get rid of that negative sign in front of the variable, you must divide the variable by what's in front of it, the negative sign. So to get rid of this and leave the variable positive, I must divide this side by -1. To get rid of this -1 and to leave it a positive a, I must divide -1a by -1. Whatever I do on this side, I must do the exact same thing on this side. So I divide the positive 10 by -1. -1 into -1a goes positive a, or a. I could write it like this, positive a, which is understood to be a positive a. I could write it like this, positive a, which is understood to be a positive a, or I could have written it like this, positive 1a, because it's exactly that, 1a, a positive 1a. But it's the positive sign. The positive sign is not usually written, and the 1 is not usually put there. So when you see a positive 1a, it usually looks like that. When you see a positive 1x, it usually looks like that, because that's what it is. So if I was to have m, b, y, they are all understood to be positive 1m, positive 1b, and positive 1y. That's just understood. You need to know that, especially when you end up with an answer like this. If I was to have -x equals 3, I can never have an answer like that, because my variable must always be positive. And to get rid of the negative, remember that this is -1x. So I must divide both sides by the number that's in front of the variable. To get rid of this -1, I must divide it by -1. So -1 into -1x leaves me with positive x, because negative into negative goes positive. Those are rules that I will put on the board later, that you must learn them. It's imperative in algebra that you learn the rules of adding, subtracting, multiplying, and dividing, the signs, because a lot of times the signs changes or the signs stay the same. We'll talk about that in just a little bit, just a moment. Let's just concentrate on the beginning of the basics of algebra. So algebra is the use of an equation to solve for the unknown. What is an equation? Two mathematical values that are either equal or proportional. So one mathematical value is a is equal to 4. That's the answer for the equation. That would be the answer, because that cannot be simplified. That cannot be simplified any further. A is 4. A is equal to 4. A and 4 has the same value. Everywhere you see A, it's equal to 4. That's the answer. And remember, it's always positive. If you have a negative sign in front of it, you have to finish solving the equation, because it's not finished. A lot of times you'll see something like this. This is just hypothetical, just an example. 2x equals 12. Remember, we are always trying to solve just for the variable by itself. What is x in this case? We just want to know what x is. We don't want to know what 2x is. We don't want to know what 5x is. We don't want to know what 10x is. We don't want to know what -1x is. We just want to know what x by itself is. Just a positive, simple 1x, because this is 2x. We don't want to know what 2x is. We want to know what x is, what x equals. And x is also 1x. And it's also positive 1x. But usually that's not written. I just say x because it's understood to be a positive and it's understood to be 1x. Please, I'm not trying to confuse you. Just follow me. Go back over this video. Please, it's imperative that you follow me and understand the path I'm taking. I'm trying to break it down to you as simple as you will see it. So, we are trying to find x, the value x by itself. So I have 2x. So to find what the value x is from 2x, what I must do here is divide by the number in front of the value. What's the number? 2. So to find out what x is, if it's 2x, I must divide by 2. If it was 5x, I must divide by 5. If it was 10x, I must divide by 10 to get rid of that number in front of the variable. If it's 3x, I must divide by 3 to get rid of that variable. In this case, it is 2x. So I divide by 2. Leaves x. 2 into 2x leaves x. Remember, that's positive. That's what I want. Is equal to, and whatever I do on this side, I must do on the other side. So I divide this side by 2, so I must divide that side by 2. 2 into 12 goes 6. X equals 6. How do I know it's right? 2 times x equals 12. And x is 6. So 2 times 6 is equal to 12. It's absolutely right. I'm not finished. I'm going to take my time until I'm satisfied with myself, that I believe in myself, that you understand what I'm showing you. I'm not going to complete this until I am satisfied that you understand what I'm showing you. This is an algebraic equation. This is an algebraic equation. The use of two values with an equal sign. And you're going to figure out what the unknown is. The unknown is x. I have 4x equals 12. So what I do here is I want to know what x is. I don't want to know what 4x is. I just want to know what x is. And to get rid of the number in front of the x, I must divide this by that number, which is 4. So I just want the value x. So to get the value x, to find out what x is right here by itself, I divide this by the number in front of it, which is 4. 4 into 4x goes x, or 1x. Same thing. But it's positive. It don't have a negative sign in front of it. That's what I'm looking for, a positive x. Bring down my equal sign. Whatever I do on this side, I do the same over here. So I divide by 4 too. 4 into 12 goes 3. So x equals 3. So 4x equals 12. And if x is 3, then 4x. Also remember, when you have 4x, this also means 4 times x. Or you might see it written like this, 4 times x. And one last way you might see it written, 4 times x, the orthodox original way of writing multiplication. So you will see 4x, which is also 4 times x. 4 times x, they're in parentheses, means multiply when they are right beside each other and there are no operations in between. It means multiply. Or 4 and a period and another 4, and the period is up in the middle. That's 4 period 4. That's 4. That means 4 times 4 means multiply. And this is the original orthodox way of writing multiplication, just a regular multiplication sign. But in algebra, you very rarely will see this. Very rare. But we know what it is. Sometimes you will see this. Sometimes you will see this. But most of the time in algebra, you'll see it like this, because that's what that means. 4 times x. 4x means 4 times x. So to get rid of the x, to find out what the x is, to get rid of the number in front of the x, I must divide it by the number in front of the x, which is 4. 4 into 4x goes x. That's what I'm trying to find. And whatever I do on this side, I do it on this side also. So I divide the 12 by the 4, and it's equal to 3. 3 over 1 or 3, the same thing. Remember, each whole number is understood to be over 1. So this is 3, it's over 1, it's understood to be a positive 3, because it does not have a negative sign beside it. Okay, I'm going to go a little further. Remember, it's imperative. I'm going to get to the rules. Do not panic yet. I'm going to give you the rules so simple that you will not forget it. But what is imperative is that during this time, you have to remember the basics. You have to remember how to add, subtract, multiply, and divide fractions. Sometimes decimals. You must know your timetables. So if you're a parent out there listening to this, please suggest to your child or your children that they learn, they study their timetables. They must remember that. And you must remember the basic things of how to add fractions, subtract fractions, divide fractions, multiply fractions, and also decimals. We must remember these things as we go further into mathematics. Here we have negative 4m equals negative 16, and they put solve. Ooh, scary. They're trying to scare me. Solve. Don't let that scare you. Because that's what we do with equations. We solve them. We break them down to the mere minimal, where we can't go any further. That's the answer right there. And I know I'm right. And nobody can scare me into doing it wrong. Because I follow my rules. I follow the methods. And I'm going to teach you everything. First, I taught you what is algebra. Algebra is the use of an equation to solve for the unknown. What is an equation? An equation is two mathematical values showing that they are equal or proportional by an equal sign. And one of the proportional value will always be a variable, and the other one always a number. Here we have negative 4m is equal to negative 16. This is a variable. Even although this is m, it has negative 4 in front of it. Any variable with a number beside of it is a variable. That's not a number any longer. If I have 2x, negative 14y, 10c, or these are all variables. This is a positive 2x. It's understood to be positive because there's no sign in front of it. That's always positive. Positive 2x. It is a variable. It's a negative 14y. You can see the negative sign. That's when you know something is negative, because a negative sign will always be there. If there's no negative sign, then it's not negative. This is 10c. I can say 10c, or I could say positive 10c, because it's understood to be positive. Although it has a 10 in front of it, it's still a variable, and it's not considered a number. It's a variable, and a and m are both considered variables. Numbers will never have a letter beside it. Numbers stand by themselves. So I have a number 12, 14, 2, 7, 6. These are numbers. They all stand by themselves, and they are understood to be positive numbers. 12 is a positive 12, positive 14, positive 2, positive 7, positive 6. Why? It doesn't have a negative sign in front of it. And remember, they are understood, all numbers understood to be over 1, and understood also to have a decimal behind them. We talked about that in the last in the decimal segment, a couple segments back. But we must remember these little things. All right. So in algebra, we use variables and we use numbers. We use variables and we use numbers. That's what's in the equation. And they asked me to solve. So here I have what I'm supposed to have. In algebra, you want to have all variables on one side and all numbers on the other side. Always. That's how you do it. You must make sure that variables and numbers are not on the same side. If variables and numbers are on the same side, you can't solve it. To solve an algebraic equation, you must separate variables from the numbers. All numbers must be on one side, all variables must be on the other side. I'm saying side. I'm saying on one side, on the other side. The side of what? The side of the equal sign. On the side of the equal sign. This is the equal sign in your equation, and the variables must be on one side of the equal sign, and the numbers must be on the other side of the equal sign. It doesn't matter which side. It does not matter. Just make sure you got all of them on one side, all numbers, and on the other side, all variables, because you cannot have numbers and variables on one side. You can never solve it like that. Please remember that. So if you're doing an algebraic equation and you have a variable and a number on one side, and then you have the equal sign and then a variable and a number over here, and you say it's solved, that can never happen. You can never solve it. To solve an algebraic equation, you must put all variables on one side and all numbers on the other side. Let's go forward. So here I have all variables on one side and all numbers on the other side. And here's the equal sign, which is the borderline. This is my borderline, my equal sign. So I have negative 4m is equal to negative 16. But I'm not trying to figure out what negative 4m is or what 4m is. I just want to know what m by itself is. What is m by itself? And if I have an equation like this and I'm trying to figure out what m is by itself, what I have to do is divide that number by whatever is in front of m. So here I have negative 4m. So I'm going to divide negative 4m by negative 4 because I want to get rid of that. Whatever is in front of this, I divide it by. Remember that. So I divide this by negative 4. You remember you can't divide by 4 because it's not 4 in front of the m. What's in front of the m? What's in front of the m is negative 4. So I have to divide by negative 4. And whatever I do on this side, I must do the same over here. Divide this side by negative 4 also. Please remember this. So negative 4 into negative 4m goes positive m. Because remember, when you're multiplying and dividing and the signs are the same, your answer will always be positive. I'm going to give you those rules in a minute. When you're multiplying or dividing and the signs are the same, your answer will always be positive. So here I have a negative 4m divided by a negative 4. So automatically my answer is going to be positive. That's what I'm looking for. I want to know what positive m is. Not negative m, not negative 4m, not negative 10m, not negative 25m. I want to know what positive m is. Positive 1m. That's what this is. This is m or positive 1m. Same thing. That's what I want. So now I've divided this side by negative 4. I must divide this side by negative 4 also. Negative 4 into negative 16 goes positive 4. Because negative into negative is always positive. So here I have m equals 4. I'm not ready to give you the rules yet. Just a moment. Just a moment. I'm going a little bit further and then I give you the 4 rules. So important. And they are very, very important because you must learn them just like your timetables. Because without the rules, you're going to get algebra wrong. We know the basics. We know that we must separate variables from numbers. Variables must be on one side and numbers on the other side. We know that. That's a rule. It must be. But there are other rules that we must learn. Give me a moment. One moment. I'm just going to do a couple more of these right here. Just a couple more. For example, bear with me for one moment here. I have 3 algebraic equations on the board. 3 of them. I have negative 3x is equal to 15. Give me one moment here. I have negative 3x is equal to 15. I have positive 2m is equal to negative 4. And I know you're supposed to be familiar with me saying 2m or positive 2m. We know it's positive. So I could have said 2m or positive 2m, the same thing. So positive 2m is equal to negative 4. And positive 1/3 y is equal to 9. We know it's positive. There's no sign in front of it. Once it do not have a sign in front of it, it's always positive. So these are my 3 equations. So in each equation, what am I trying to find? In the first one, I need to find the value of x. Negative 3x equals 15, but that could not be my answer. I don't want to know what negative 3x is. I want to know what x is, positive x. So to get rid of this negative 3 in front of this negative 3x, I must divide this by negative 3. Whatever is in front of it, that's what I divide by. And whatever I do on this side, I do it on this side also. So negative 3 into negative 3x goes positive 1x. Or x. Same thing. And negative 3 into positive 15 goes negative 5. Because when you're multiplying or dividing and the signs are different, your answer will always be negative. That's another rule. I'm going to talk to you about the rules in a minute. When the signs are the same, your answer will always be positive. When the signs are different, your answer will always be negative when you're multiplying or dividing signs. I'll talk to you about those rules. I'll write them down. Give me a moment. So the first one here is 1x or x is equal to negative 5. So anywhere you see x, you put negative 5. So negative 3 times negative 5 is equal to positive 15. So true. Because when you're multiplying or dividing and the signs are the same, your answer will always be positive. I'll give you the rules, but I'm going to talk about them as I go. So we are finished with the first one. And here we have, let me write it a little bit higher. I have 2m is equal to negative 4. But I'm not trying to figure out what 2m is. Even though it's positive. Yes, it's positive. That's good. My answer should always be positive. But my answer will never be 2m. I don't want to know what 2 or 5 or 6 of the number, of the variable is. I want to know what that variable by itself is. The positive value of that variable. The positive value of m. And how do I do that? I divide it by whatever is in front of it. So 2 into 2m goes m. When you're multiplying or dividing and the signs are the same, my answer will always be positive. So positive 2 into positive 2m goes positive 4. Whatever I do on this side, I do on this side also. I divide this side by positive 2. So put my equal sign, and positive 2 into negative 4 goes negative 2. Because when you are multiplying or dividing and the signs are different, your answer will always be negative. So m equals negative 2. Let me do one more. This one right here, 1/3 y equals 9. You will see this on a test somewhere. 2/3 x equals 14, 1/5 m equals 3, 1/2 x equals 20. You will see them again somewhere. The key thing is to know how to solve them, because this is so easy. Because what I'm trying to figure out when I have an equation like this is just what the value of y is. The positive value of y. Or the positive value of whatever the variable is. In this case is y. A variable is just a letter. The letter y is a variable y. Same thing. So to find out what the positive value is of this, I just divide it by whatever is in front of it. And it's a 1/3 or positive 1/3. So I divide this side by a positive 1/3. Whatever I do on this side, I do the same on this side. So I divide this side by 1/3. 1/3 into 1/3 y goes y, or positive 1y. Same thing. And 1/3 into 9, remember how long we did fractions. The first segment was fractions. And I showed you how to divide fractions. You cannot divide by a fraction. Remember that segment? The first segment. Brush up on basics mathematics. Fraction. Number 1. Mathematics number 1. Fraction. That's the first segment. So how do you divide by a fraction? You have here 9. It's an whole number that's understood to be over 1, divided by 1/3. That's what this is. This and this, they're the same thing. So yes, I have 9 over 1 divided by 1/3. I can't divide by a fraction. So I must change this to multiply, to a multiplication sign. So that's going to become 9 over 1 times, and anytime I change the division to multiplication, I invert or flip the number that comes behind it. So now this becomes 3 over 1 because I flip it or invert it. And 3 9s, 27 over 1, or just 27. Same thing. 27 over 1 or 27, they are the same exact thing. So 1/3 of 27 is equal to 9, which is so true. 1/3 of 27, because anywhere you see y, you're going to put 27. 1/3 of 27, or 1/3 times 27 is equal to 9. That's multiplying fractions. We'll get to the rules in just a minute. Give me a moment, please. Now remember these little steps. There are going to be so many different variations of algebraic equations that they come to you with. You have to be able to figure it out. One very simple one that you will see often, and it tricks a lot of us, and I'm going to show it to you. I have here Jack is 4 years older than his brother Jim. Jack is 4 years older than his brother Jim. Together, they are 46 years old. How old is Jim? They could have asked you how old is Jack. They could have asked you how old is either one. You just have to know how to set this problem up as an algebraic equation, because they give you numbers and they gave you numbers and they gave you variables, and you should be able to put it as an equation and work it out to figure out how it's equal or proportional. So the unknown, we have two unknowns. Jack is 4 years older than his brother Jim. So we don't know what Jim is and we don't know what Jack is, but we know that Jack is 4 years older than Jim. So I'll start with Jim by saying Jim is X. This is Jim. Give me a second here. This is Jim. Jim is X. This is Jack. So we don't know what Jack is, but we know that Jack is 4 years older than his brother Jim. Jack is 4 years older than Jim. So if Jim is X, Jack is X plus 4, because he's 4 years older than Jim. And together, they are 46 years old. Together, they are 46. So together, when you add Jim up to Jack, they're equal to 46. So you have Jim, Jack, when you add them up, they're equal to 46. That's how you set it up. You will see this on a test somewhere. But it's not difficult. Apply it. Look for the unknown. The unknown in here is Jim and Jack. But we know that Jack is actually 4 years older than Jim. So we find out Jim, we call him the unknown, X, and then his brother is X plus 4 because he's 4 years older than him, and together they are equal to 46. So X plus X plus X plus 4 is equal to 46. Remember this. Earlier I said that in an algebraic equation, you cannot have variables and numbers on the same side. You'll never be able to solve it. You have to separate variables from the numbers. You have to have all variables on one side and all numbers on the other side. It doesn't matter. It doesn't matter what side. It does not matter. I always want to carry the smaller variable to the larger variable. It comes out easier to me. That's just my opinion. When you carry the smaller variable to the larger variable, it comes out easier. But when I look here, all the variables are on this side already. I do not need to move them. There are no variables over here. What I need to move is this 4, this number that has no business with the variable. It has to go over the other side where the other number is. You must get rid of it from over here because you cannot have numbers and variables on the same side. So to get rid of it, I move it across the equal sign. Remember, the equal sign is my border. Those are my equal signs. And I move it across here. And listen, this is a rule. I want you to remember this rule is not difficult. Anytime you change sides, whatever, whether it's a variable or whether it's a number, whichever one, anytime you change sides, the sign changes too. So if you're moving from this side and it's a positive and you come across the border, it's going to become a negative. If you're moving from this side and it's a negative and you're coming across the border, it's going to become a positive. And the same thing vice versa. If you're moving from over this side and it's a positive, when you come across here, it becomes a negative. And you're moving from over here and it's a negative, when it comes across here, it becomes a positive. So simple. You change side, the signs change also. When you change sides, the sign changes also. So here we have variables. The variables are going to stay on this side because that's what I want. I have two variables. I have x plus x. Those are the two variables I have. Positive x and positive x. X plus x. That's what I have over here already. And over here, I have 46, which is going to stay over there. And I'm going to bring this positive 4 across the equal sign, and it becomes negative 4. And please, 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 anytime you see negative 4, or anytime you come across the border and it becomes negative 4, that's also the operation. You don't have to put plus negative 4 or negative plus 4. Don't do that. You're going to confuse yourself. When you change side, the sign changes. So it's a positive 4 here. When I bring it across, it becomes a negative 4. That's what you put there. So x plus x is 2x is equal to 46 minus 4 is 42. And I'm trying to find the value of x, not 2x. So I divide it by what the number in front of it. I divide it by the number in front of it to get rid of the number in front of it, to make it a positive value by itself, a positive variable, a positive letter. That's what I want for my answer. In this case, I must divide it by 2. And whatever I do on this side, I do the same on that side. So 2 into 2x goes x, which is a positive x, because when I'm multiplying or dividing, and my signs are the same, my answer will always be positive. Here I have a positive 2x divided by a positive 2. My answer will be a positive x. Is equal to, I'm dividing positive 42 by positive 2. My answer is going to be a positive 21. So x equals to 21. So how old is Jim? Jim is x. Remember? Jim is x. So Jim is 21. So let's figure it out. If Jim is 21, this is Jim. Jim is 21. And Jack is 4 years older than Jim. So 21 plus 4 is 25. And together they are 46. Exactly right. That is so correct. That's their ages. Jim is X. X is 21. Jack is 4 years older than Jim. So Jack is X plus 4, which is 21 plus 4. So that's 25. 25 and 21 is 46. That is a correct proportional equation. It is solved. This is equal or proportional to that. Please remember these. You'll see them again. Rewind this video. A lot of times you see um, you see a problem like this. For example, 2x plus 4 is equal to x minus 6. I just created a problem. I just made it up. Because what I have here, I have variables and numbers. It's an algebraic equation. And I must use a proportional sign to solve it. I have the proportional sign. It's an equation. How do I solve it? I must separate my variables from my numbers. I have 2x plus 4 is equal to x minus 6. I have 2x plus 4 is equal to x minus 6. I have variables and numbers. My borderline or my equal sign is the borderline. So I must get all variables on one side and all numbers on the other side. I have 2x and x, they are my variables, and I have 4 and negative 6, they are my numbers. The key thing for me, what I like to do, is I always try to bring the smaller variable to the bigger variable. I leave the bigger variable where it is. I always start with the variables. That's just mine. You don't have to. You could start with the numbers, but it's just a rule that I accumulate over time. I start with the variables. I bring the smaller variable to the bigger variable first, because I know I have to have all variables on one side and all numbers on the other side. The sign of what? The equal sign. So here I have 2x is the bigger variable, so I leave it on this side and I bring this positive x across the border, and anytime something positive cross the border, when it crosses it becomes negative. Remember, you change side, the sign changes. So positive x comes across and it becomes negative x. Ha! And remember that negative also means the operation. So this is 2x minus x. Same thing as 2x negative x. Same exact thing. Don't let nobody tell you different. Don't let nobody trick you. That's all you have to do. And over here, I'm going to have all my numbers. So what number do I have over here already? I have negative 6. I just drop it down. And I'm going to bring this positive 4 across the border. And since it's positive over here, when it crosses the equal sign, it becomes negative. So this is it. I just separated all my variables, put them on one side, and all my numbers, I put them on the other side. I could solve this equation now. Very simple now. Because you must separate the variables from the numbers first and foremost before you do anything else. And when you change sides, the sign changes. So 2x minus x, I have 2x's, I take away 1. Remember, this is 1x. So that leaves me with x. Positive x. And I have negative 6, negative 4. When I'm adding or subtracting and the signs are the same, I add the number and keep the sign. That's another rule I'm going to write down in just a minute. So this is negative 6, negative 4, that's negative 10. I add the numbers and keep the sign. So x equals negative 10. Anywhere you see x, you put negative 10. So negative 10, 2 times negative 10, that's negative 20, plus 4, that's negative 16, is equal negative 10, negative 6, which is negative 16. Negative 10, negative 6 is negative 16. When the signs are different, adding or subtracting, you add the number and keep the sign. Let me write the rules down right now. I'm not going any further. I'm going to write the rules down for you when it comes to adding, subtracting, multiplying, and dividing signs, negatives and positives. These are the rules that's going to take you through algebra. You must know them. The first rule when adding or subtracting and signs are the same, you add the numbers and keep the sign. This is the first rule. Now you must have noticed that I do not have enough space on the board. So I'm going to write one rule at a time, and you get a clean sheet of paper and you write the rule down. And then when I write the other one, you write it down under the first one on a sheet of paper. Keep them together so you remember the rules. You can study them together. When adding or subtracting and the signs are the same, you add the numbers and keep the signs, or keep the sign. Let me give you an example. Signs are the same. 6 plus 4. Or 10 plus 6. Or -12, -8. Let's talk about this for one moment, please. This is so important. Let me give you an example of what I just wrote. When adding or subtracting and the signs are the same, you add the numbers and keep the sign. The signs are the same here. So I have +6, +4. Both of them are the same. This is +6, +4. So this is equal to, when the signs are the same, I add the number and keep the sign. 6 plus 4 is 10, and I keep the sign. So that's a +10. Or I could have just written 10, because it's understood to be positive. It's a +10, a +6. This is equal to a +16. I didn't have to put a positive sign. I didn't have to put a positive sign in front of it, and I did not have to put a decimal behind it, because all these are understood. Every whole number is understood to have a positive sign in front of it, a decimal behind it, and is understood to be over 1. We spoke about that already, but I didn't have to write it like that. The signs are the same. I had the number and keep the sign. 10 plus 6 is 16. The sign is positive. That's understood. I just put 16 down. It's understood to be a +16. This is the rule. When the signs are the same, adding or subtracting, you add the numbers and keep the sign. I have -12, -8. The signs are the same. When adding or subtracting and the signs are the same, you add the number and keep the sign. Add the numbers and keep the sign. So the signs are the same, -12, -8. So I had the numbers. 12 plus 8 is 20, and I keep the sign. So -12, -8 is -20. Let me do 3 more. This is rule number 1. When adding or subtracting and the signs are the same, you add the numbers and keep the sign. A lot of people will do this. Why would I do that? Why would I do that? This is confusing. That's why you don't never see me write like that. because these are two signs that are beside each other and they mean multiply actually, and the dominant one is going to be the negative sign, because when multiplying and the signs are different, your answer will always be negative. So positive negative 5 is the same thing as negative 5. So I didn't have to put no positive sign there. That's confusing. It's negative 4, negative 5. And when the signs are the same, adding or subtracting, you add the numbers and keep the sign. So this is a negative 9. Number 2, I have 2 plus 6. It's also positive 2, positive 6. The same thing. Positive 2, positive 6. You're adding or subtracting. The signs are the same because you have a positive 2 and this is a positive 6. They're the same. So you add the number and keep the sign. 2 plus 6 is 8. It's a positive 8. Or I could have done that. Same exact thing. And the signs are the same right here. Adding or subtracting and the signs are the same. You add the numbers and keep the sign. Why do I say subtracting? It's negative 12 minus 20. Negative and minus are the same. Negative 12 minus 20. Minus 12 minus 20. Negative 12, negative 20. Same thing. Don't let nobody trick you. So when the signs are the same, I add the number and keep the signs. 20 plus 12, that's 32, and my sign must be negative because I'm adding or subtracting, and my signs are the same. In this case, I'm subtracting, and the signs are the same, so I add the number and keep the sign. So negative 12, negative 20, my answer will be negative 32. That's rule number 1. Rule number 2. When adding or subtracting and the signs are different, you find the difference and use the sign of the larger number. You have to pay special attention to this one, please, because the sign of the larger number is a little tricky. So I want you to bear with me. When adding or subtracting and the signs are different, you find the difference and use the sign of the larger number. Please write that rule down. When adding or subtracting and the signs are different, you find the difference and use the sign of the larger number. Find the difference. Find the difference means to subtract. You find the difference mean to subtract. So, for example, my signs are different. Negative 2, positive 6. When I'm adding or subtracting and my signs are different, this is rule number 2. You find the difference and keep the sign of the larger number. Negative 2, negative 6. What's the difference between 2 and 6? The difference is 4. And you use the positive sign because it's the bigger number here. So negative 2, positive 6 is equal to positive 4. I could put 4 or positive 4. It's the same thing. Please remember that. If I was to have 10 minus 3, what this actually is, one moment, I have 10 minus 3. What this actually is, this is a positive 10, negative 3. 10 minus 3, positive 10, negative 3. I have two numbers here. I have a positive 10 negative 3. So it's 10 minus 3. Same thing. The negative sign and the minus sign are the same. So 10 minus 3 is equal to, I find the difference and use the sign of the larger number. Remember, the rule applies. So you find the difference. 10 minus 3 is 7. And the sign of the larger number, it's positive. So it's understood to be positive. I did not have to put a plus there. It's understood to be positive. So 10 minus 3 is 7. The rule applies, no matter how simple it is. We are just used to seeing this. But this right here, we are not used to seeing. If I was to have negative 10, positive 3, I changed it around a little bit. We are not used to seeing this, but we are used to seeing this. 10 minus 3. Because we got so used to that, it becomes the norm. But actually, if I was to put positive 3, negative 10, positive 3, wow, now I have a whole other problem. Now I have negative 10 plus 3, or negative 10 positive 3. Positive and plus is the same thing. Negative and subtract is the same thing. So when the signs are different, you find the difference and use the sign of the larger one. So this is the larger number. So the signs are different. I find the difference. The difference of 10 and 3 is 7. And I use the sign of the larger one. So negative 10 plus 3 is negative 7. Trust the rules. Trust your rules. Learn your rules. Apply your rules. You have to know them. And one last one. This is positive 3, negative 15. I could have said positive 3, negative 15, or I could have just said 3 minus 15. The same exact thing. Because the 3 is understood to be positive, and this 15 is understood to be negative. So that's 3 minus 15. Same exact thing. So when the sign, now you have to apply the rule, because sometimes this is not familiar territory. We are not used to seeing this. This is not something we see every day. We're like, what the heck is that? That is 3 minus 15. Huh? But it's so simple, because once you know the rule and apply it, you can't go wrong. When adding or subtracting and the signs are different, you find the difference and keep the sign of the larger one. So the difference between 3 and 15 is 12, and the sign of the larger one, that's negative. So my answer is negative 12. Rewind this video, please. Rewind it so you could see what I'm trying to show you. So this is rule number 2. So the next one would be when multiplying or dividing, and the signs are different, your answer, when multiplying or dividing and the signs are different, your answer will always be negative. Remember this rule. This is multiplying and or dividing. When multiplying or dividing and the signs are different, your answer will always be negative. Your answer will always be negative. So for example, I'm multiplying and my signs are different. I have negative 3, 4. Or I could have written it negative 3 times 4, or negative 3 times 4. All of them are the same thing. Negative 3 times 4, negative 3 times 4, negative 3 times 4. The signs are different. That is what I want to get your attention on. And when multiplying or dividing and the signs are different, your answer will always be negative when the signs are different. So negative 3, positive 4, or negative 3 times positive 4 is negative 12. It will always be negative once the signs are different and I'm multiplying or dividing. You must remember the rules. I have positive 5 times negative 2. I'm multiplying. My signs are different. How do I know this is a positive 5? It does not have a sign in front of it. To be a negative, it must have a negative sign in front of it. Once there are no signs in front of it, it must be positive. Even if it does not have a positive sign, it's understood to be positive. So positive 5 times negative 2, the signs are different. Multiplying or dividing, the signs are different. My answer will always be negative. 5 times 2 is 10. My answer is negative 10. If I have negative 7 times 3, when I'm adding or subtracting and my signs are different, when I'm multiplying and or dividing and my signs are different, my answer will always be negative. Negative 7 times positive 3, my signs are different. 3 times 7 is 21. My sign is negative. When multiplying or dividing and the signs are different, your answer will always be negative. This is rule number 3. That is rule number 3. I gave you 1 and 2. 1 and 2. When adding or subtracting and the signs are the same, you add the number and keep the sign. That's rule number 1. When adding or subtracting and the signs are different, you find the difference and keep the sign of the larger number. That's rule number 2. When multiplying or dividing and the signs are different, your answer will always be negative. That's rule number 3. I'm going to give you rule number 4. When multiplying or dividing and the signs are the same, your answer will always be positive. So, let's look at rule number 4. This is rule number 4. Please look at it. When multiplying or dividing and the signs are the same, your answer will always be positive. Remember that. So my signs are the same. I have 3 times 4. They are both positive because they don't have a negative in front of them. So my answer will always be positive. 3 times 4 is 12. If it was negative 3 times negative 4, that would be a little different. Why? Because my signs are different. My signs are the same, but they are negative. But it does not matter, because when multiplying or dividing and the signs are the same, your answer will always be positive, even if you have 2 negative signs, like I do here. Because it's multiplying, it will always be positive because the signs are the same. So negative 3 times negative 4 equals positive 12. So both of these will give you a positive entity. When the signs are the same. If I was to have minus 4 times minus 2, the signs are the same. I'm multiplying. So signs are the same. When you're multiplying and the signs are the same, your answer will always be positive. Always be positive. Negative 4 times negative 2, my answer is a positive 8. And the same as positive 4 times positive 2, because my signs are the same, my answer will always be positive. It is a positive 8. And when I'm dividing, it's the same exact thing. If I'm dividing, if I was to have 10 divided by 6, if I was to have 10 divided by 6, I know I reduce. 2 into 10 goes 5, 2 into 6 goes 3, so this is equal to 5 over 3, which is also equal to 1 and 2/3. But because I'm dividing and my signs are the same, my answer will always be positive. If I had negative 12 divided by negative 4, my signs are the same. I'm dividing, so because I'm dividing and my signs are the same, my answer would always be positive. Negative 4 into negative 12 go positive 3. Please remember this. These are the rules when it comes to multiplying or dividing, adding or subtracting fractions. I'm sorry, not fractions. Signs. This is algebra. Signs. So please remember that. You must remember the rules. I ask you to rewind the video and write the rules down. Learn the rules because you have to know them. So, what is algebra? Algebra is the use of an equation to find out what the unknown is. What is an equation? The equation is two values using an equal sign to figure out the proportionality of one to another. So, if I was to have 2x plus 4 is equal to negative 3x minus 2. I'm just throwing something up there. I don't know what the outcome will be. I'm just going to apply the rules because I know what they are. The first rule is I have an algebraic equation and they ask me to solve it. To solve it, I must figure out what are my entities, what are my values. I'm working with 2x's and negative 3x and plus a positive 4 and a negative 2. I have variables and numbers. When you have an equation, you cannot have variables and numbers on the same side. You must separate them. You put variables on one side and numbers on the other side. It does not matter what side. But I develop a little rule. My rule is I carry the smaller variable to the bigger variable at all times. Which one is the smaller variable? I have positive 2x and I have negative 3x. Anything positive is always bigger than anything negative. So negative 3 is the smaller one. So I will leave positive 2x on this side and I'll take the smaller variable, which is negative 3x, and I'll bring it across. So when I bring that negative 3x across the border, which is the equal sign, it becomes positive 3x instead of negative 3x. When you change sides, the sign changes. So now, I bring negative 3x across, it becomes positive 3x. So all my variables are on this side. I have 2x, and I bring the negative 3x across, it becomes positive 3x. So there are no other variables. So now I must, on the other side, I must have my numbers, because they have to be separate from the variables. And over this side, on this side, I already have negative 2. And I bring this positive 4 that's on this side, I bring it across the equal sign. And it becomes a negative 4. So here I have 2x's plus 3x's, that gives me 5x. 2x plus 3x equals 5x. Bring down my equal sign. And I have negative 2, negative 4. When I'm adding or subtracting and my signs are the same, I add the numbers and keep the sign. Negative 2, negative 4, 2 plus 4 is 6, and I keep the sign because the signs are the same. So 5x is equal to negative 6. A lot of us would think that the equation is solved. It's not. Because I'm not trying to figure out what 5x is. I'm not trying to figure out what the value of 5x or 10x or 3x is. I want to know what x is, positive x. So to do that, I divide it by what's in front of it. In this case, it's 5. And whatever I do on this side, I do it on this side. So 5 into 5x goes x, and 5 into negative 6, remember, positive into negative. When the signs are different, multiplying or dividing, your answer will always be negative. So my answer is going to be negative. 5 into 6 goes 1 time and 1 over 5. So x equal 1, x equal negative 1 and 1/5. These are the rules. This is all algebra is about, variables and numbers. And to solve the equation, an algebraic equation, you separate the variables from the numbers by moving all variables on one side and all variables all numbers to the other side. It does not matter. It does not matter which side. My answer here is negative 1 and 1/5. I put it right here. Because what I'm going to do now, instead of putting all the variables on this side, I'm going to move them on the other side, because my answer must be the same. So here I have variables and numbers, the same equation. I'm just going to change the sides. Instead of having numbers on this side, I'm going to put variables. And instead of having variables on this side, I'm going to put numbers. My answer must come out the same. So here I have my equal sign. So instead of bringing the smaller variable to the bigger variable, I'm going to bring the bigger variable to the smaller variable. So that is negative 3x is on this side already. So I leave it on this side, and I bring the positive 2x across, and now it becomes negative 2x. Because it's positive over here, when it crosses the equal sign, it becomes negative. So all my variables are over on this side now. So now I have to put all my numbers on this side. The number that's on this side already is 4, positive 4. I just drop it down, positive 4. I could have just done that because that's understood to be positive 4. And I bring my negative 2 across the borderline, and it becomes positive 2. So 4 plus 2 is 6, is equal to negative 3x, negative 2x. When the signs are different, when the signs are the same, I add the number and keep the sign. When I'm adding or subtracting and the signs are the same, I add the numbers and keep the sign. It doesn't matter if it's a variable or a number. So in this case, we have negative 3x, negative 2x. I add the numbers, 3x and 2x, that's 5x, and I keep the sign, negative 5x. I never want to know what a negative x is, or negative y, or negative 3y, negative 5y. I always try to solve for the positive value of the variable itself, the positive value of x in this case. So to solve for the positive value of x, I divide both sides by what's in front of it. In this case, it's negative 5. That must give me a positive value. Negative into negative goes positive. Adding or multiplying or dividing, the signs are the same. My answer will always be positive. So negative 5 into negative 5x goes positive x. That's what I'm looking for. Whatever I do on this side, I do it on this side. So I divide this side by negative 5, so I must divide this side by negative 5. When I'm multiplying or dividing and the signs are different, my answer will always be negative. 5 into 6 goes 1 and 1 over 5. So that's negative 1 and 1/5. There goes my answer that I had for the first one when I had all the variables on this side. No matter what side you go on, your answer will always be the same. Once you know the rules of multiplying, dividing, adding, and subtracting signs. I thank you so very much for looking at this segment. I hope it was so very informative. Believe me, I covered a lot of material. Please, please, please look back at the video, because I broke it down as simple as possible so you know what a variable is, what an algebraic equation is, how do I solve it, what do I do with the variables and the numbers, what the signs are when you're multiplying, dividing, adding or subtracting. You have the whole system, algebraic system, laid out right here for you. Thank you so very much. Okay, and please remember our first responders, our frontline workers, our essential workers. Black Lives Matter. Get your feet off our necks, please. Thank you so very much for this segment, and the next segment will be 48 hours after this. Thank you.